All right, I made a mistake when I was doing part B. So I picked between 6 and 7, and I should have picked between 7 and 9, so for the 108. So I went ahead and fixed that. We're going to go into Desmos and fix that as well, and should change our answer to the correct answer, which is now a negative 59.582. So we would say that this is approximately negative 59.58. It was 582, right? 582. Ooh, 582, and this was in feet cubed per hour. Let's take a look at part C. So let H of T represent the total amount of snow in cubic feet that Janet has removed. So we're talking about what is removed in time in the driveway of T after midnight. H is expressed as a piecewise function with domain from 0 to 9. Express H as a piecewise function. Okay, so basically what we need to do is we need to figure out what she has removed in each of the hours, and we're going to base it off of kind of what's here, because this is the rate at which she moves snow off the driveway. But they want us to take it to the total amount, which means I'm going to have to go back to an integration because I'm going from a velocity basically back to a position. So we would want to say something like in the first interval, so my first interval is between 0 and 6. So for between time 0 to time 6, H of T is equal to whatever's in the driveway at time 0 plus whatever we get when we integrate this G of T function. So G, and I can't use T because we're going to go from 0 to T. So we're going to put a dummy variable in there, which I'm going to use an S for no particular reason. And then if we actually look at what's going on, H of 0, okay, I look at H of 0, it's actually going to start with, she hasn't removed any snow to begin with. And then when I go to integrate this, it's really at the integral of 0. So the integral of 0 from 0 to T of 0 ds, so all of this is going to just be 0. So for the first 6 hours, she doesn't remove anything. She doesn't really start till hour 6. So for between 6 and 7, H of T equals whatever she removes whatever's there at hour 6 plus the integral from 6 to T of G of S ds. All right, so we know that this was what was previous. So really she still hasn't removed anything yet at hour 6. It's still all sitting there, and we're going to integrate. And you'll notice we're going to integrate whatever this value is right here. So we're going to integrate 125 from 0 to T of 125 ds. All right, and then when I integrate that, the 0 is going to go away. We would end up with 125s, and we would have to plug in 0 to T. Sorry, not 0. This should have been a 6. 6 to T. So when I plug that in, I end up with 125. I could just use that as a coefficient, and then we know we have to do T minus 6. And we could just leave it like that. And then we're going to go for the 7 to 9, H of T equals whatever's in the driveway at time 7. And then we're going to integrate. Again, we're going to follow that same pattern from 7 to T of G of S ds equals. This time we know that at H of 7, we know we have 125 that's been removed. So I get to start with that number this time. Plus the integral from 7 to T of, and then I'm going to use the next piece down. We're going to use 108 this time. 108 ds. So this ends up equaling 125 plus 108 s from 7 to t. So it's 125 plus 108, and then it would be t minus 7. So officially, I guess we could write that as a little bit cleaner piecewise function. So h of t actually equals 0 from t is 0 less than t less than or equal to 6, 125 t minus 6 for 6 less than t less than or equal to 7, and 125 plus 108 t minus 7 from 7 less than t less than or equal to 9. I know this is a longer video, sorry about that. I'm trying to get it all out of the way because of the power issues. So how many cubic feet of snow are on the driveway at 9 a.m.? So we're looking at, this is looking at a total. So we're trying to figure out our total at 9 a.m. So that means I need to integrate from 0 to 9 how much snow is in the, or how much snow is fallen minus how much snow has been removed. So I'm going to go into, I know how much has been removed at 9 has to be, is modeled by, if I can get to move this function right here. My other function, I'm going to use my calculator to actually calculate. So, and I'm going to plug a 9 in for that t. So this is really the same thing as saying from 0 to 9 of f of t dt minus 125 plus 108, 9 minus 7. Then we're going to go ahead and put that whole thing into our calculator, in this case into Desmos. So I'm going to type in the integral from 0 to 9 of f of t dt, and then we're going to subtract, I'm going to use some parentheses, 125 plus 108 times 9 minus 7. I guess I could do 2 in my head if I wanted to. And then something did not go right there. 125 plus 108 minus. All right, I figured out what I did wrong. I had a negative 9 in there I accidentally typed, so it should be this 26.334 feet cubed. So we would say it's 26.334 feet cubed.